Have you ever wondered what would happen if Earth grew 100 times its size? Will it grow into a massive planet? And how big can it get? A larger planet may have some similarities to Earth, but the differences in our ecosystems, evolution, and the fundamentals of reality will astound you. In this video, we'll take a look at what would happen to us if the Earth suddenly grew 100 times larger. If you're really curious, we'll tell you the story of the greatest disaster ever. It started with small jolts from beneath the ground. Nobody paid much attention to them. People assumed these were minor tremors. The jolts became much stronger and more frequent in just a year. They became full-fledged earthquakes in some areas, causing extensive damage to cities and villages. Worse, previously dormant volcanoes began to erupt. People all over the world began to sound the alarm. Scientists talked a lot about climate change and its impact on humanity, but it was clear that no one had definitive answers. The power and frequency of earthquakes and volcano eruptions increased over time. We abandoned large, sturdy apartment buildings in favor of lightweight 3D printed houses. Neighbors were assisting one another, and entire towns banded together to build strong communities and prepare for the worst. And the worst happened sooner than we anticipated. If the diameter of the Earth were doubled to about 16,000 miles, the planet's mass would increase eightfold, and the force of gravity would be twice as strong. Bodies with the same construction and mass as our flora and fauna would weigh twice as much and collapse if gravity were twice as strong. It would be timber for tall, thick trees like redwoods. Large, sun-seeking plants could still grow, but they would require stiffer architectures made of cellulose fibers or another material entirely. To support their weight, animals' legs would have to be thicker. According to Neil Commons, a physics professor at the University of Maine, the appearance of humans would be determined by the evolutionary demands placed on our biological forefathers in a higher gravity world. If our forefathers had to run fast and fight hard, we'd be burly. Otherwise, we'd be thin and light. NASA's Kepler spacecraft whizzed through space for nearly 4 years, surveying our corner of the galaxy. It scanned over 150,000 stars for planets the size of Earth that belong to other solar systems. The mission was a success, as Kepler discovered numerous examples of a type of planet known as a super-Earth. These distant planets may look familiar. They're rocky, smaller than gas giants, close to their star, and have a thin atmosphere. They are, however, much larger than the blue marble. These super-Earths are 2 to 10 times heavier than our planet. Because there are so many super-Earths out there, it begs the question, what would happen if our planet were 2 or even 10 times its current size? According to Mickey Rosenthal, a doctoral candidate studying planet formation at the University of California, it's possible that Earth and the other inner planets of our solar system were headed in that direction. One theory is that Jupiter grew so large that it cut off access to cosmic building blocks needed to grow the inner planets, effectively starving them. Whatever the reason for Earth's current size, there is no way to truly know what would happen if it became supersized. Scientists, on the other hand, have some theories based on what they've learned about our distant cousins. For starters, Mount Everest, and every tree in California's Sequoia National Park would be shorter, because increasing the size of a planet while keeping everything else constant increases gravity. You'd be heavier if Earth were twice its current size, because the force of gravity increases as the planet's density and radius increase. It would require more energy to resist gravitational pull, so today's structures would not be strong enough to stand as tall as they do. If we assume that the density of the Earth remains constant, doubling the radius increases the planet's mass by an order of magnitude. Because the surface gravity has doubled, most plants and trees have collapsed. Because any animal the size of a dog or larger cannot run without breaking a leg, large predators cannot move quickly enough to catch prey. Due to the conservation of angular momentum, the planet now rotates 32 times slower. A day lasts more than a month. This causes massive temperature imbalances between the planet's light and dark sides, causing windstorms that flatten all buildings. If the atmosphere doubles in size, so does air pressure. This is still breathable, and the additional oxygen helps to compensate for the increased effort required to pump blood up to your brain. Although the thicker air makes flying easier for birds, most must land on water to cushion the impact of the stronger gravity. Earth would experience more collisions with a larger planet and a stronger gravitational field, according to Rory Barnes, a theorist at the University of Washington who studies planet habitability. As a superplanet, Earth's greater gravitational pull would effectively attract more and larger asteroids, making Armageddon-type collisions more likely than they are now, according to Barnes. If the hypothetical super-Earth were even larger, say 10 times its current mass, dramatic changes in Earth's interior could occur. The iron core and liquid mantle would be 10 times larger as well, and with more gravity acting on a larger mass, the pressure beneath the Earth's surface would rise. According to Barnes, the high pressure could cause the iron core to solidify. Convection currents in our partially liquid core currently generate Earth's magnetic field. However, if the core solidified, the currents would cease and the magnetic field would be weakened or eliminated, according to Barnes. Barnes believes that if our magnetic field faded or disappeared, it would be disastrous for life on Earth. Our magnetic field protects life on Earth from the nastiness of space, according to Barnes. Without it, charged particles in space, also known as solar storms, could collide with Earth. And according to him, these tiny particles can cause a variety of issues, including DNA fragmentation and an increased risk of cancer. Barnes also mentioned that a larger interior could make super-Earth more volcanically active than it currently is. As the planet's radius grows, there is more energy inside and fewer places for that energy to escape. He believes that more volcanic eruptions are likely. Plate tectonics would be different as well on a super-Earth. However, the precise effect is still unknown. A larger mantle would also be hotter, potentially resulting in more vigorous convection currents that push plates around more. In contrast, under high pressure, the crust could be completely fused together and plate tectonics would cease to exist. Based on the super-Earths discovered thus far, scientists cannot be certain that Earth would be habitable if it were a super-Earth. The Kepler Space Telescope excelled at detecting planets that were very close to their star, much closer than Earth is to the Sun. The majority of known super-Earths are almost as close to their star as Mercury is to our Sun. According to Hilke Schlichting, an associate professor of astrophysics at the University of California, Los Angeles, for Earth to be comparable, it would need to have an orbit of about 100 days. That orbit might be habitable in systems with stars smaller than the Sun. But if our Earth were that close to the Sun, all of its water would vaporize, according to Schlichting. In other words, Earth would be out of the habitable zone and would essentially become a steam planet, according to her. Surprisingly, many of the discovered super-Earths appear to be water-rich, like entire water worlds, according to Rodrigo Luger, the Flatiron Research Fellow at the Simon Foundation Center for Computational Astrophysics in New York City. He believes that these planets formed from large chunks of ice and then migrated close to their stars, causing their ice to melt. These planets, however, may not be habitable because their deep oceans freeze to a solid ice layer. The intense pressure of the super-deep ocean forces water molecules into a solid state rather than low temperatures. According to Luger, this ice layer prevents any interaction between the atmosphere and the planet's interior, which means there is no carbon cycle or mineral exchange, which regulates Earth's long-term temperature via an interaction between the atmosphere and the mantle. That does not promote habitability, at least not in the sense that we know it. In reality, scientists have more questions about super-Earths than answers, and according to Luger, we don't fully understand the physics of our own interior, let alone that of a planet many solar systems away. We don't know what would happen if the Earth grew larger or moved closer to the Sun, but so far, it appears that we are very fortunate not to be living on any of those planets. And with that being said, it's time to end our video. Subscribe to the channel for more amazing videos like this. We'll see you with another interesting video.